Good morning, everyone. And thank you for being here and joining us to kick off day 2 of Universe. I hope you had a fantastic time yesterday, meeting Hubbers, others in the community, and learning from each other. At GitHub, our mission is to be the home for all developers. All developers. That's a pretty monumental task when you think about what it really means. As Nat shared yesterday, there are over 40 million developers on the GitHub platform today. 40 million. That's more than the population of most countries. And those developers are writing code in over 370 different languages, and for a huge variety of purposes, from healthcare to machine learning to finance, video games, automotive, mobile, nonprofits, and more. And these folks are developing software all over the world. Over 80% of open source is now developed outside of the US. So there are all of these developers building all of this software for so many different reasons and for people all over the world. These folks have different workflows, different tools that they depend on, and different ways that they collaborate across their teams. We're lucky to work with some incredibly talented developers at GitHub, but there's no way that their creativity can match that of the over 40 million developers using GitHub today. That's why the ecosystem is so important to us, and why delivering an open platform with robust APIs is so core to what makes GitHub GitHub. Now, we talk a lot about developers, but another way to look at the ecosystem is in the dependency graph and how packages depend on one another. We might be working with vastly different problems in different languages from places all over the world. But everyone building software today is reliant on the broader open source community. After all, 99% of software projects depend on open source. So each time you pull in an open source package, you're pulling in all of that package's dependencies as well. In fact, open source projects on GitHub have over 180 different package dependencies. And some of the most popular open source projects have a huge number of projects that depend on them. For example, the NPM packages have over 3.5 million projects that depend on them. So an issue in one of those packages can cause problems for thousands or even millions of projects that depend on it. At GitHub, we feel it's our responsibility to ensure we're giving developers to build great, safe software so that we can truly depend on our dependency trees. And by safe, I mean secure. Now, normally, security conversations are about fear, but I don't see it that way. Security is the enabler that allows us to benefit from the exponential productivity impact of open source. If we can build applications and consume open source with confidence, then nothing stands in our way. Now, we know that we can't secure the world's code on our own. No one company can do that. Our goal is to enable the world software community to secure the software that we all depend on. I'd like to invite Jamie Kuhl, our VP of Security Offerings, to walk through how we're approaching security at GitHub. Welcome, Jamie.
Thanks, Erica. Now, at GitHub, security is something that we take incredibly seriously. So much of the world's development now happens on GitHub that it's something that we think of not just as an opportunity, but really a responsibility. So I want to spend the next few minutes and talk about our overall approach to security. And along the way, I've got some pretty cool announcements to show you as well. The place I want to start is really with the simplest of all possible scenarios, developers not leaking the credentials to their application. And the reason I want to start there is because even in this most simple of examples, it shows that it's a problem that we cannot solve by ourselves. So the Open Web Application Security Project keeps a running list of the top 10 web app vulnerabilities, and it has the types of things that you would expect: SQL injection attacks, cross-site scripting. But I actually think that the next time they update that, they need to have a special category all to itself just for developers checking in their application tokens into their source repository, because they do it all the time. I know this because just in the last month, we've detected over 800,000 potential tokens that have been committed into GitHub public repos. The reason why we're able to know this is that we have a service that scans repos looking for potential tokens. So we'll find something that looks like a token and then help go through a remediation workflow to get the developer to update the code to something like what it should be. But think about what it takes for us to really go and do this. There are so many different services and so many different types of tokens out there. How do we at GitHub know that this was a token? And even if we knew it was a token, how do we know it's actually an active token that could be used? It's not our service. And even if we knew it was an active token, what do we do about it? We can't go and remediate it. It's not our token. So the answer to this is we partner. So we work with a whole set of partners to secure this. And the way that this works is that they tell us what their tokens look like. When we find one that matches, we tell them about that possibility, and they can go and check to see if it's an active token and then take the right action for their service. And it means that if you're a user of one of these services, you have to worry a lot less about your developers leaking your tokens. And I'm thrilled to announce that today we have 4 new partners that are joining us to detect tokens: HashiCorp, Postman, GoCardless, and Tencent Cloud. I'm thrilled to have them, and if there's anybody listening here that is interested in participating in this with their service, please reach out. Now I want to talk about a problem that is just slightly more complicated, which is trying to secure the open source supply chain. So, like Erica mentioned, the depth and complexity of applications today is exploding, and it's all powered by open source, and this is fantastic. The place where this really becomes real for me is with the dependency graph. You can go on any repo today on GitHub and look and see what the dependencies of it actually are. So pick your favorite repo, any open source project, for example, and go. And you will see that there are so many dependencies of dependencies of dependencies of dependencies. It's kind of crazy. But this is great. You get thousands of committers that are helping you go faster in building your application. But it also means you have thousands of committers that you have to take care of in terms of risk exposure. So what happens when something goes wrong here? Open source has to be something that we can all use with confidence, we can use with safety. And because so much of it lives on GitHub, this is a problem that we really wanted to see what we could do about. So we stepped back and we asked ourselves, who are all of the types of participants that are involved in this supply chain? And there are quite a lot, from security researchers to developers, maintainers, and organizational security teams. And they all have to be able to work together as part of this. If we look at what a typical workflow looks like, you see all of these roles, and you see all of the problems that come out. Let's start with security researchers. These are the folks that find the majority of the actual security vulnerabilities. But even today, in 2019, and even when you have access to much of the source code, finding those vulnerabilities is often an extremely manual process. And then once you find the issue, what do you do? Like, if you don't know anything, you don't know anybody in the project, how do you reach out and tell them about this security vulnerability without disclosing it to the world? And then maintainers. Maintainers already are busy enough, but they now have to be responsible for fixing these vulnerabilities. And because open source repos are public, you don't typically want to fix security vulnerabilities in the open because you don't want to disclose them. It means you often can't even use the same tools and workflows that you're used to when you fix these vulnerabilities. And then you have to notify all of the people in the world that are using this project. How do you go and do that? And then finally, developers have to actually update to this application. And how many times have we seen a security vulnerability that was found and fixed and months later exploited because the application simply didn't update to the new version? And kind of the worst from my standpoint is that these same type of vulnerabilities happen again and again and again. How many times have we read an article about a buffer overflow issue or a cross-site scripting issue? The same types of problems come up and up again and again. So we've been putting a lot of energy into seeing what we could do to help all of these roles work together to try and fix this problem. But it's easier to show than it is to talk about. So let's go look at a demo. So we're going to go through that end-to-end flow, and we're going to start as a security researcher. So I'm a security researcher. I found a vulnerability. And let's say I found a vulnerability in the public Webpack project, and I want to report it. How would I do that? Well, the logical thing to do would be to go where the Webpack maintainers live, which is at the Webpack repo on GitHub. And then the logical thing to do would be to go where you report issues to Webpack, which is on their issues page. So if I create a new issue, you'll see that there's something that's telling me the path I should take for reporting a security vulnerability. So we support security policies which allow maintainers to specify how they would like to see security vulnerabilities reported to their repository. Now, once you know about a security vulnerability as a maintainer, it's time to fix it. And that's where security advisories come in. Security advisories are a concept that provide a mechanism for a maintainer to work in private, even on a public repo, to fix that security vulnerability and then ultimately to publish it to the world. So here I have an example of a draft security vulnerability where it hasn't been fixed quite yet, and I want to actually go through collaborating. So this is a space much like a pull request where the team can come in and discuss the vulnerability in private. I can invite whoever I want. So if I wanted to invite even the person that originally reported the security vulnerability, I can. I can specify metadata like how severe the vulnerability is, what package it applies to, what version it applies to, and go through fixing it. And to fix it, you also get a private fork, which is literally what it sounds like, a private Git fork for you to make the change before it's actually published in live. Now, once you've made the change, it's time to tell the rest of the world about it. So you can publish this advisory, which will tell us about it, and then we will take the next steps, which we'll get to in a second. But one of the things that I'm excited is now officially live today is that as a maintainer, you can request a CVE directly from this page. And what this means is CVEs are the mechanism that the broader security community uses to communicate about vulnerabilities. But the mechanism for getting a CVE has a little bit of a tax to it. So GitHub can now issue CVEs on behalf of open source projects, and that will allow us to connect the open source community to the rest of the security community. So I'm very excited about that. Now, once you've published this advisory, what happens? Well, it goes into our advisory database. So the advisory database, this is a collection of all of the vulnerabilities that we know about at GitHub, whether it was one that was reported directly to us via security advisories, or whether it was one that we pulled in from one of the public feeds like the National Vulnerability Database. If you've ever gotten a security alert from GitHub, it's because it was part of our advisory database. Now, we think this data is incredibly important, and we think this vulnerability data is something that everyone needs to help keep our software safe. So I am thrilled to announce today that the GitHub advisory database is available for free for everyone. You can access it via the web, or you can access it via APIs. You can search by CVE or particular strings. You can filter it down to particular severity levels or specific ecosystems. If we were to look at the Python ecosystem, and then let's pick one of the recent more severe security vulnerabilities, you can drill in and you can get a description of exactly what's wrong with that vulnerability. And kind of the exciting thing for me is because this vulnerability was reported natively on GitHub, we have a level of traceability with vulnerabilities that we have rarely had before. So I can see for this one the actual repo that it was fixed on. And in fact, because this one was filed by a security advisory, I can go to the actual security advisory on the actual repo that this was reported on. And in this case, the team even has more information like links to issues where the vulnerability is being discussed. And if you've ever tried to find out more information about a vulnerability, a vulnerability online, this kind of connectivity is something that has been sorely needed, in my opinion. Now, the vulnerability is now in our advisory database. The next step is to alert the people that are using this particular dependency that they need to take action. So the way that we do that is we take the data in the advisory database, and we match that up with the dependency graph. I mentioned this earlier, but this is where you can view all of the dependencies and the dependencies of the dependencies of dependencies of the dependencies. We could go for a while here as part of this. But if any one of those dependencies has a version that has a vulnerability in our database, you will get a security alert. You will get a security alert in the web portal. You will also get a security email. And for those of you that have been receiving security emails already, I have good news. We've been listening to you. So in addition to all of the security emails you already get, we will now send you an additional security email every 15 minutes until you fix that vulnerability. It's completely configurable. If 15 minutes is too frequent, you can dial it down to 5 minutes. Our infrastructure team has been laying fiber so that we can send as many emails as it takes to secure the world's software. You guys think I'm joking, don't you? Seriously, though, we have heard your feedback that sometimes the number of security alert emails can be a little bit voluminous. So we recently shipped a feature that internally we lovingly called Garden Hose as opposed to Fire Hose. And what Garden Hose lets you do is configure how you want to receive security alerts. So if you would rather receive a digest of all of the security alerts and only get that once a day or once a week, you can now do that. OK. So I've gotten a security alert. The next thing is to get the developer to fix it. So to make that easier, we support a feature called automatic security updates. And what automatic security updates does is it will generate a pull request which will update the version of the dependency to the one that has the security fix in it. And in this case, it's showing me all of the changes in total that I'm going to pick as part of this change. So it means if you marry this with actions or the CI system of your choice that's validating your change, all the developer should have to do is come into the pull request that was generated, review it, and merge it. This is all powered by Dependabot. Dependabot joined GitHub at Satellite last May, and I am thrilled to announce that it is now fully integrated into GitHub. It is generally available, and it is protecting millions of repositories today. Now, this was for a flow for one repo, but many organizations out there have tens of repos, hundreds of repos, thousands of repos, tens of thousands, and as a customer yesterday told me, in some cases, hundreds of thousands of repos. And it can be hard to keep track of the state of all of your repos. So we've been working on that problem with something we call Dependency Insights. And what Dependency Insights does is give you a view across all the repos in your organization so you can see what the total set of outstanding advisories are, how severe they are, and what the dependencies that you have. You can filter this with different views. In this case, I can filter it down to see the dependencies that have the most set of security advisories. If I just pick one and drill in, I can see that, in fact, this particular version of this dependency has 12 security advisories. That's not ideal. But then I can also go see that there's actually only one repo in my organization that's using that, so I can decide what the next action to take is. Maybe I need to go give them a little kick. Maybe this repo needs to be archived. I have that data to be able to do that. OK. Now, if you were paying close attention, you'll have noticed that we tackled a bunch of the problems that I talked about, but there were two that we didn't. One was how do security researchers find the vulnerability to begin with? And the other is how do we stop these vulnerabilities from happening again and again and again? So those two problems are exactly why, in September, SEML joined GitHub. So how does SEML help us tackle those two problems? It brings with it an amazing technology called CodeQL, which is essentially a semantic code engine. So what does that mean? It takes your code and it transforms it into a database that is now queryable. So you can now query that database as a security researcher to go and hunt for vulnerabilities in that code. You can then take those same queries and use them to make sure as a developer you're not introducing similar types of vulnerabilities. So I'm really excited about this, but it's also way easier to show than it is to talk about. So let's take a look. So I am on the NetData repository. NetData is a popular real-time monitoring solution. And they've been using CodeQL to make sure that they don't introduce new security vulnerabilities into their changes. So every time a pull request is created, CodeQL is run to go look for new potential vulnerabilities. And at some point in this change, which was a pretty big one, we actually detected with CodeQL 3 potential vulnerabilities, and one of them was a cross-site scripting vulnerability. So let's go look at that. So I'm going to jump over, and we're going to look at those. And this particular vulnerability is in main.js. Main.js actually has 2 vulnerabilities, but in the interest of time, we're just going to look at the second one. And we'll look at this cross-site scripting one. So this shows me the piece of text where it thinks I have a vulnerability. So what is a cross-site scripting vulnerability? It's essentially an attempt by an attacker to take a string that they sent in some form, maybe a URL, and get it injected into your DOM so that it can then run script and do things like steal your cookies and data. And I can kind of see from this line why this might be a problem, because it is setting something into my DOM, and there is a variable that's got data coming from somewhere. But this could be OK. Think about what it actually takes to find a real cross-site scripting vulnerability. You need to know where the data is coming from and that that data might be unsafe. You then need to know how that data might be used that could be dangerous, like putting it into the DOM. And then you need to be able to track that data as it moves through your program, however it goes from point A to point B. This is a pretty hard problem. But that's exactly what CodeQL does. So if I drill in, I can see that the data from the source is actually being read in from a variable from a separate frame. Separate frame, different URL potentially. This is where the cross-site scripting comes in. And then it gives me the stack trace as that data flows from point A to point B through different variables, and eventually getting down to the place where it is inserted into the HTML, thus the potential cross-site scripting attack. Now, this vulnerability was found by running one of the many queries that are available. So this particular project has 3 different languages in it. Each of them have a different set of queries. In fact, we have over 2,000 built-in queries that have been authored to find different vulnerabilities. And because one of those queries existed that knew how to detect this type of vulnerability, the net data team was able to make a fix to not just insert straight, but to make sure it's coming in as text before this change ever got merged into master. So this type of vulnerability, when you talk about static analysis, is the real kind that you want to find, because it's not theoretical. It's a real exploitable one. They're also the hardest to find. And the reason why we were able to find this one is kind of twofold. One, because the tech here is kind of cool. But the other one is because someone authored, in this case, a security researcher, a security expert, authored this query that knew how to go and find it. So that data is the key thing, that connection between the work that a security expert did to the workflow of a developer. So this, I think, is one of the key things and one of the key opportunities. Because if you talk about the entire set of roles that need to participate in this, there's an incredibly important one, which is the security researcher. So there's a great opportunity for us to take all of the amazing work that the security community is doing, the security experts, the security researchers, and connect that directly into the workflow and the lives of the millions of developers on GitHub to help make all of this software that we're using safer. So I'd like to invite Nico Wiseman on stage to tell us more about that. Nico is one of the world's foremost security researchers, and I couldn't be more thrilled to have him here at GitHub as a colleague, helping us solve these problems. So please welcome Nico Wiseman.
Thank you, Jamie. Hi, my name is Nico, and I'm part of a tribe that hunts for gaming code. What started for me as a hobby in the 90s somehow ended up turning into a job. And that job eventually turned into a career, and today, some 20 years later, I find myself part of an ever-growing community whose skills have since become indispensable in modern society. Initially, in those early days, my own little tribe focused mostly on network infrastructure and managing user access. But their natural next step was to focus our effort toward what those users were actually using to interface to the infrastructure that was under our care, basically a software. So with time, a significant chunk of this tribe focus shift to integrate it into the software development lifecycle. And it was with that shift that a vibrant and thriving community spawned. A community that was solely focused on ensure software behave the way it actually intend to behave. Our job became to explore and document the unintended states of the software that runs our world. And more important, what actually security impact those safe spaces might have. I'm sure by now everyone guessed who my tribe is. I'm a hacker, I mean a security professional. And my tribe is the information security community. The information security community started as a small group of people on IRC that, for those that are young here, it's sort of like Slack, but without the animated GIF. It has since grown into a massive community that attracts thousands of people to a security conference around the globe to discuss the latest research. What used to be an esoteric pursuit of gaining or preventing access in creative ways has since become a full-blown industry. However, along the way, my tribe has committed some cardinal sins. Sins that haunt us to this day and have prevented us from integrating effectively into the very fabric we aim to protect. One of our largest sins, I believe, is our historical antagonistic relationship with IT, QA, support, and most important, the software development teams. For too long have we, as an industry, taken an ivory tower position, doling out our judgment on code and product quality without offering any tangible, deployable solution. Just providing a single example of flows and expecting people to just figure it out. The information security industry should be a facilitator, not an innovator. And we decided to do something about that. So as such, I'm really thrilled to announce today the GitHub Security Lab. What is the GitHub Security Lab? The GitHub Security Lab will be the home of security researchers at GitHub. Our mission will be to hunt for vulnerabilities in open source projects, to build tooling that will help secure code bases, as well as partnering with other security teams across the industry to build bridges between the research community and the wider software community. We have a dedicated handpick of highly skilled security researchers. Our team will hunt and fix vulnerability in the most important projects. We'll go beyond just racking up CVEs and also enable the open source community to act as a force multiplier for the security research community through integrated vulnerability variant analysis. In essence, our security research will be your security research. To date, the team has collected more than 100 CVEs, and some of them are critical vulnerabilities in really big projects. And this is only a small example of what we'll be able to achieve together. A Spanish philosopher once said that those who cannot remember the past are condemned to repeat it. This quote, to me, represents the very essence of what CodeQL is aimed to prevent: the repetition of the past, and as a consequence, their mistakes. The main concept behind QL is to model known vulnerabilities down to their essence, extracting the code patterns, and then convert them into queries. Later, we will use those queries as seeds to uncover vulnerabilities in your code base. We want to help developers write secure code and keep that old tradition of killing one vulnerability at a time, which basically does not scale, especially consider that codes are not static entities. They're moving targets that change continually with every commit. To that end, I'm very excited today to tell you that we are releasing CodeQL for free for open source and academic use. Yeah. We are also releasing a VS Code extension that will help streamline CodeQL integrated into your workflow. Let me now invite Kevin Backhouse to stage. Kevin's a fantastic security researcher. I have found vulnerabilities in Apport, libssh2, the XAU kernel, and many, many other projects.
Hi, I'm going to show you a quick demo of a vulnerability that I found earlier this year in Facebook Fizz. Fizz is Facebook's open source TLS implementation. So that's the software that does the HTTPS part of https://facebook.com. As you can imagine, that's critically important software for Facebook. And the bug that I found could have caused a serious outage at Facebook and Instagram. So because Fizz is so important, Facebook have put a lot of effort into making sure that it's secure. So it's been extensively fuzz tested and audited. And from having looked at the source code myself, I'd say that it's very high quality. So the bug that I found with CodeQL had managed to slip through a very tight net. So what I'm going to do first is I'm just going to show you a demo of the exploit proof of concept that I wrote. So I've got a Fizz server running here. And in this terminal here, I'm going to run the attack. So you can see that that's extremely cheap for an attacker to run. That just sent off a 64 kilobyte message to the Fizz server and then disconnected. And you can see over here now, I've got top running, that the Fizz server up here is using 100% of a CPU core, and it's become completely unresponsive. So let me just shut that down. So how did I find this vulnerability? This is VS Code, and over here is the CodeQL extension. And up here, I've got a database for Fizz loaded. Jamie mentioned these databases earlier in his talk. So what the database is the source code for Fizz converted into a form that is now queryable. And over here, I've got the query that found the vulnerability. So what I was looking for was integer overflows in the Fizz source code. Integer overflows are difficult to find with a text-based search like grep, because they tend to be implicit in the code. But with CodeQL, it's easy because the database contains not just the text of the source code, but also other information like types. So what I'll show you first is some query results. So this was a simple query that I wrote, just looking for potential integer overflows. And you can see that there's quite a lot of results. And what I really want to know is whether it's possible for an attacker to put some malicious data into an incoming message, and for that to actually trigger one of these integer overflows. So the query that found the bug is here. I used our taint tracking library to do that. So with taint tracking, what I'm able to do is I'm able to say, I'm only interested if there's a source of network data that flows to a sink where there might be an integer overflow. And you can see the result of that query over here. Let me just hide this here. And now there's just one result. And it's given me a dataflow path as well. So this is the same dataflow path technology that you also saw earlier in Jamie's demo on lgtm.com. And these dataflow paths are incredibly valuable for me as a security researcher, because they allow me to figure out why the query thinks that there might be a problem in the code. And if it has found a problem, then it also helps me to then construct an exploit for it. So what you can see here is that the dataflow path starts out with an endianness conversion there. And that's often a telltale sign of data that's coming out of a network packet. And then that's used here to read an unsigned 16-bit integer into this variable length. And then the final step of the dataflow path, this is where the integer overflow happens. So this plus equals, what my proof of concept does is it triggers an integer overflow, which causes length to wrap around and become 0. And then this loop up here ends up going back to the beginning of the message and parsing it again, which is why there ends up being an infinite loop in the code. So you can see that this bug would have been very difficult to find without CodeQL. So that was the end of my demo. I'm going to hand back to Nico now, who's going to talk about the impact that this is going to have for software security in general. Thanks.
Thank you, Gail. That's a great bug, but if you didn't understand the bug, you don't have to worry about it. The whole idea of what we're trying to do here is that we will soon be able to transform the great work of research like Kev and leverage it across multiple code bases to prevent those bugs to ever happen again. I would like to introduce now Rob Fletcher. Rob is the head of product security at Uber. He and his team are responsible for product security. His team mission is to help Uber developers write more secure code, a mission that is very similar to our own, and we have the privilege of working with him in the past. Rob, why don't you tell us more?
Hello, hello. My name is Rob Fletcher, and I'm a security engineering manager at Uber. I'm excited to speak for a few minutes today about how we've used LGTM and CodeQL to really strengthen our application security program. Several years ago, we launched a 3-part test phase to explore the efficacy of LGTM, and we were really excited to see the results that came from the control flow analysis and the tainting functionality. Since then, we've rolled out LGTM more broadly, and it's become an important part of our vulnerability management strategy, helping to create a more robust lifecycle between manual findings and automated findings. For example, we take our manual findings and plug that into CodeQL writing, and on average, we've been able to find 3 true variants for every individual manual finding that we write a query for. Besides those obvious results of getting more vulnerabilities, it's really raised the ceiling, too, on how we can scale with the company when we couldn't do that as well previously. Instead of finding one vulnerability in one code base, we can write a CodeQL query that allows us to find that vulnerability in all of our code bases in an ongoing basis. As modern development workflows continue to get faster, really the only way security teams can be successful and scale with the company is automation, and LGTM has really helped us there. Besides that, LGTM has also allowed us to be a little more creative in the way we find vulnerabilities. As an example, the idea of a dangerous source making its way into a vulnerable sink is a relatively well-known paradigm in security for finding vulnerabilities, but the flexibility of CodeQL allowed us to kind of start thinking in a more creative way on how we could flip that paradigm on its head. And so what we started doing is looking for leaky or sensitive sources making their way into leaky sinks as a way to identify sensitive data leakages in things like request handlers. So borrowing a friend's quote, CodeQL is a really great way to ask questions about your code base, and I'm excited to see how we can continue to use CodeQL in creative ways as our application security program grows. It's with all that context that we're excited to be partnering with GitHub on the Open Source Coalition, and I look forward to seeing what the future of CodeQL holds. Thank you.
Thank you, Rob. We are excited to have an initial set of partners today that all have committed to contribute in different forms, such as tooling, computer infrastructure, funding, and hours of research time, all to help secure the open source software for the community. We want to invite others to join the same effort. Well, our partners' commitment to open source security really constitute a formula of results to really make the difference. We need our entire community on board. And what better way to invite the community participation than offer tangible incentives to assess the security of open source software? And who better to discuss this subject than Mihu Shan, Director of Product Management at HackerOne?
Thank you, Nico. At HackerOne, as a part of our mission to make the internet safer, we believe that protecting open source is our social responsibility. After all, like most companies, open source software powers HackerOne. And that's why we are thrilled to see how much GitHub is investing in open source security. They're really in one of the best positions to have meaningful change. In case you're not familiar with us already, at HackerOne, we work with a community of over 500,000 hackers, or security researchers, to help them disclose vulnerabilities to programs. Often, programs pay a bounty for the security research that they receive. One of the ways that we support open source is by sponsoring the Internet Bug Bounty along with GitHub that pays out bounties to some of the most important open source projects. Another is that open source projects can use a version of our popular bounty offering for free, called the HackerOne Community Edition. And today, I'm happy to announce that we're upgrading the Community Edition to include the best feature suite that we offer. And we're not stopping there. We're also eliminating the majority of our program fees so that more of the bounty goes to the hacker, which will increase incentives for open source security research. And finally, I want to briefly talk about 2 things we've learned running bug bounty programs. The first is transparency. The more open a program is, meaning the more that it discloses vulnerabilities and the more people it invites to hack, the better results it gets. The next is that, put simply, it helps a lot to get paid. When programs start paying bounties, or when they start increasing their bounties, they get better results, which means more secure code. That's why facilitating payments will have such a deep impact on open source security. And with that, I'd like to hand it back to Nico.
Thank you, Michu. There is a famous Linux law among security people that states that given enough eyes, all bugs are shallow. Really, this to be true. That is why we are fully committed to rewarding your time for looking at open source code. And to that end, we're establishing two main bounties to reward vulnerability research on open source projects. The first one, we call it the bugs layer. This bounty will reward security researchers that create barren queries that have found multiple real-world vulnerabilities with associated CVE numbers. The second one, we call the all for one, one for all. This bounty will reward security researchers who create queries that are such of high quality and usability that can be mainlined into our shipped toolchain, thus directly benefiting the entire open source community. Finally, I want to invite everyone, maintainers, developers, security researchers, and everyone else involved in the software development community to visit our website, where you can download tools such as CodeQL and the new VS Code extension, receive information about upcoming events, and learn about the commitment that some of these key players in the open source community have made to improve the security of our shared ecosystem. Please check our website, follow us on Twitter, and stay tuned for the amazing things that are coming. We have captured the flag at Connect Space after the keynote. You can meet the security team, so please visit us. And now, let me welcome back Erica.
Thanks, Nico, Jamie, Miju, Rob, and Kevin. I couldn't be more excited about the work that we're doing in the security space. It's great to see this range of companies coming together to work on issues for the benefit of the broader community. And this is just the beginning. I can't wait to see this community grow and flourish, so please do check it out. Now, let's look at another way to get involved in the ecosystem, and that's via Actions. Actions lets you automate any part of your development workflow, from running tests to triaging issues to deploying to a cloud. We built Actions to be fundamentally extensible. In fact, the GitHub repo graph is the Actions ecosystem. You can take actions from anywhere in the open source community, edit them, and reshare. When you fork a project with an action in it, the action comes right along with it. To date, over 1,200 actions have been published in the GitHub Marketplace. That's up over 250% since August. I'm going to invite Erica Cotto, who runs our partner engineering team, to the stage to talk to us about some of the work our team has been doing with partners to enable some really cool actions for GitHub. Welcome, Erica. Now, just to set the record straight, I'm Erica B. This is Erica K, and we are not to be confused with Erica A, our SVP of sales. There's so many Ericas.
Hi, Erica. We have been thrilled by how many have embraced Actions so quickly. Here are just a few of our partners. Our partners have created Actions to let you build very cool workflows between GitHub and their products and projects.
Yeah, I love seeing the engagement around actions. It's such a great example of how the ecosystem can provide new functionality to GitHub users and make it easier to use other products and projects with GitHub. Erica, what are some of your favorite actions you've seen so far?
Well, to start, I'd like to highlight Terraform. Managing infrastructure has always been complex. Now imagine having large multi-tier applications or multi-cloud deployments. HashiCorp's Terraform allows you to codify infrastructure and lets you deploy to any cloud. This simplifies the provisioning process so much. In this example, we want to inverse the color scheme on this Octocat site and have it automatically deploy to Netlify with our development workflow. When a pull request is made in GitHub, the Terraform plan is triggered from GitHub Actions, which will check to make sure your plan really matches your expectations. Then, when the pull request is merged, the GitHub Actions will kick off the Terraform apply, and you're good to go. I know this is a simple example, but this totally automates your deployment from code to cloud.
It's impressive how Terraform allows you to deploy to multiple platforms so simply. Great work, HashiCorp.
Another action that I'm excited about is the white source action. With GitHub packages, you can discover and publish packages within GitHub. White source offers container security scanning, so when you include the white source action, those Docker images you're publishing can be scanned for you. When the scanning is complete, you will receive a full report back with known security vulnerabilities and license information. This example workflow demonstrates the white source action being kicked off when a Docker container is published to GitHub packages. The workflow will then add the security report to an artifact in GitHub. You can also visit the white source site to see the visual representation of your report. This essentially lets you bake security into your workflow, and it's so simple.
I think we've shown that security is paramount to us at GitHub. It's great to see this partner integration that enables you to scan your containers for known security vulnerabilities before you put them into production. Well done, white source.
And last but not least, Twilio lets you build really cool communications workflows via APIs. They have written an action that makes triggering an SMS from GitHub super simple. Having an automated workflow is great, but there may be times when you need to alert someone through SMS for some high-priority item. We've created a workflow here. When a pull request is made for a slide presentation, it can count how many errors are included and send a notification when it detects a threshold value. Clearly, there are too many errors in this presentation.
I don't think you can ever have too many errors. Seriously, though, how cool is it that you can trigger an SMS from GitHub so simply? This is awesome work from Twilio. Thanks so much, Erica. And of course, that's just a small sample of the over 1,200 actions available today. And now that Actions is generally available, they're available to everyone. So please go ahead, check them out in the marketplace, and even build your own. Thanks so much, Erica. I talked earlier about our mission at GitHub, to be the home for all developers. And we know that developers want choice. Who doesn't? We're committed to delivering on this and ensuring that every part of your development lifecycle is swappable when you're using GitHub. This includes CI providers, security solutions, cloud platforms, and more. Actions takes this to heart. You can automate anything, replace any part of your workflow, and integrate easily with other tools. On that note, I'd like to invite Claire, a principal engineer from Amazon Web Services, to the stage to show us an awesome code-to-cloud workflow that they've built. Welcome, Claire.
Hi, I'm Claire Ligori. I'm a principal engineer on the AWS Containers team, and I'm a big fan of containers. I love that containers can help us to share our applications with others, and I love that containers can help us to deploy our applications to the cloud. I like that there's this easy, standardized way to describe how to build my application for a container with all the dependencies built right into the container image. I like that when I share that image with you, I don't have to make any assumptions about what Linux flavor you're running or libraries you have installed. I can simply share this image with you. And then it's as easy as Docker pull and Docker run for you to have my super cool application running on your laptop. So it's that easy. And then when you get to the cloud, now you can scale out to multiple copies of your application running in containers for high scale. You can scale out to multiple applications across many different containers. But you start to need something to manage all of these containers for you, to help you deploy and scale and keep them running all the time. At AWS, we have a broad portfolio of services to help you run your containers in the cloud. The Elastic Container Registry, ECR, will help you to store your container images and share those applications with others. We have two services to help you manage and deploy and scale containers: the Elastic Kubernetes Service, EKS, for your Kubernetes workloads, and the Elastic Container Service, ECS. We have two options for ECS for where your containers run: EC2 and Fargate. So for example, if you use ECS to deploy and manage your containers, you can create a resource called a service, where you tell ECS, I want to run 15 copies of my application all the time. ECS will keep those containers running. And you can give 3 EC2 instances to ECS to run those containers. Or you can take advantage of Fargate. Fargate is serverless compute for your containers. So you can tell ECS, I still want to run 15 copies of my application, but I want to use Fargate. So you don't have to have any EC2 instances to scale or manage or patch those instances. You can simply focus on building your applications, packaging them into containers, and deploying them to the cloud without worrying about the underlying compute for those containers. I specifically focus on developer tooling for ECS and Fargate, so I'm super excited to be here today talking about GitHub Actions for ECS, Fargate, and ECR. I think that GitHub Actions can help us to smooth the way to getting our code into the cloud. I think a lot in my day-to-day life about what are those little frustrations we have as developers every day? What are those things that slow us down from getting our code into the cloud? And I think about what are the integrations that we can create for ECS to help make that a smooth process. So today, I'm really excited to announce that AWS and GitHub have collaborated on a set of 4 GitHub Actions that are in the GitHub Marketplace today. So in order to show you these 4 actions, I'm going to take you through a sample day in the life of a developer who's using ECS, Fargate, ECR, and these GitHub Actions. So to do that, I'm going to use mythicalmisfits.com. This is an online adoption agency for mythical creatures. You can select different characteristics to find your favorite mythical creature, and then view their profile to find out more information about them. I happen to like Coco the dragon quite a bit. I think she's pretty cute. So I'm going to go ahead and hit this like button, this little heart. So this is a containerized application with multiple microservices behind it. So I have a like microservice. So this is generating the API that's driving that heart button, that like button. So we can go ahead and try it out. And I'll paste in the ID for Coco the dragon. She's pretty cute. So now Coco has 2 likes. So as I said, this is a containerized application. This microservice is running on ECS and Fargate. ECS is keeping 3 copies of my application running at all times, and it's running on Fargate. So if I go over to the EC2 console, I have no instances running. I can simply focus on deploying my applications in containers and not on those instances. Here's my Docker file. So this is such an easy way for me to specify, here are my Python dependencies, here's my Python code, do a little bit of linting in there to make sure my style is good, and then here's the command to actually run that. And then this is the actual Python Flask code that's driving that API. But one of the things we have a problem here, there's no unlike API. I can't actually unselect that heart if I decide I don't like Coco anymore. So I'm going to go ahead and build that today and push that out to my application. So the first thing I do on my laptop, I run Docker build. I got to get my workspace set up. But it looks like the build is broken. Looks like some linting rules have failed. So I'm going to go ahead and see who actually broke the build. Who on my team broke it? And it's Coco the dragon. That's weird. What is she doing in my Git repository? She says, I tested this locally on my laptop, so it totally works, I promise. And haven't we all heard that from our teammates and maybe from ourselves at one point or another? So I think this is one of those first things that slows us down day to day as developers from getting our code into the cloud. So I'm going to automate this away with GitHub Actions. So the first thing I do is I have this check workflow. On every pull request, it's just going to run Docker build. This is such an easy way for me to make sure that that build is never broken and I don't get slowed down by my other teammates. So to see this in action, I have my unlike API ready to go. It's in a pull request. My teammates can review this code in GitHub. I've written that unlike API in my Python Flask application. And then my teammates can see that the checks have passed, and they've seen that my custom GitHub action check has run successfully, and it's ran that Docker build command. So this is the same thing that I could do for any containerized application that I stored in a GitHub repository. I can have that really simple check run every time there's a pull request. So now we've seen that it's successfully built. Now I need to deploy. Now is the second time where I have something slowing me down from getting my code into the cloud. What we're looking at here is a task definition file for ECS. This is basically the configuration I need to give to ECS to run my container. Things like, what image do I want to run? What environment variables do I want to set? But the image ID changes every time. I have a unique image ID that I need to go and fill into this file. Then I need to deploy this file to ECS. So this is a multi-stage process. It's kind of manual. It's error-prone. I don't really like to do it. I just want to focus on writing my code. So I'm going to, again, automate this away with GitHub Actions. So this is using those 4 actions that AWS has published today. This is going to run on every push to the master branch. First thing that happens is it's checking out my source code that just got pushed to the master branch. Next is the first GitHub action we've published today, configure AWS credentials. This is taking AWS credentials that I've stored in GitHub Actions secrets and configuring the environment so that other actions can use them. Next, I'm logging into ECR. This is where I'm storing my container images. Next, I'm going to go build and push that image into ECR. So the tag for this image is going to be the commit ID, and it's going to push it into the registry that came out of that login ECR action. So this is pretty much what you would do for any containerized application. Docker build and Docker push with this unique ID. And then I need to take that ID and fill it into the task definition. So this is the third action that we've published, render task definition. It's going to take that unique image ID that was generated from the commit ID and fill it into my task definition for me, replacing that to-do fill-in string. And then last but not least, the fourth action, deploy task definition. So this is going to take that file, deploy my image and the configuration around it to ECS, and wait for that deployment to be successful. So let's look at it in action. I'm going to merge in my unlike API pull request. And because I'm merging into master, that's actually going to kick off automatically my deploy action here. So as soon as I push into my repository, I can see that this deployment is in progress. And we're quickly going through checking out the code, configuring those AWS credentials, logging into ECR, and we're on to the build for the Docker image. So it's pulling in all of my Python dependencies, copying in all of my Python code, running linting, and then finally it's going to push into ECR. So at this point, I could share this application with others, and now I'm going to deploy this application to the cloud. So now that I have this unique image ID with that commit ID for the commit, it's filled it into my task definition automatically, and now my deployment is in progress. So looking on the ECS console, we can watch this deployment in progress. So I've told ECS I want 3 copies of my application. So I now have 3 copies of the old and 3 copies of the new while the deployment is in progress. And then we can go and we can look at the Events tab and actually watch what's happening under the hood. So one of the things we'll see is those new containers have been started up, and they're being added to the load balancer. So anyone who's going to Mythical Misfits right now is actually able to see the unlike API in action. And then it's going to start deregistering the old version that doesn't have the unlike API from the load balancer. And it's going to drain connections first so that we don't have any more requests going to those tasks. And then finally, it's going to have shut down all of the old containers. And so now what we see is that we now are back to only 3 copies of the application, all running that new version of the application. So then when we go back to the GitHub action, we can see that this deployment is successful, and it waited for it to be successful in ECS. And so right in my GitHub repository, I can see that I've now deployed successfully to the cloud. So we can try out this unlike API. I'm going to again paste in the ID for Coco the Dragon. She broke the build. It's an unlike for me for Coco the Dragon today. And so now she's back down to 1 like. So I encourage you to check out mythicalmisfits.com for an online workshop to get started with ECS and Fargate. And you can check out in the GitHub Actions tab in your GitHub repository today, you can see the Deploy to Amazon ECS starter workflow to help you get started continuously deploying to ECS and Fargate. So thank you so much for having me today, and I'm going to hand it over to Erica.
Thank you. Thank you so much, Claire. Such great work from you and the AWS team. With that, I'd like to invite another partner, Dan Belcher, from Mabel, to talk about a great action that they have built. Welcome, Dan. You are Dan Mabel, right?
Yeah. Call me whatever you'd like. Well, thank you very much, Erica, and good morning, everyone. If you're not familiar with Mabel, we're in the business of making automated end-to-end browser testing easy. So with Mabel, you can create automated tests in minutes, plug those tests into your CI/CD pipeline, run the tests in the cloud at scale across all major browsers on any deploy. And then Mabel does 2 things that are really interesting. We collect a tremendous amount of data with every step of every test, and use that data to make tests not be brittle and not be flaky, 2 of the problems that have plagued UI tests for quite some time. And then secondly, we analyze that data automatically and discover risks or issues in your deployments. Things like visual regressions, performance regressions, new JavaScript errors, and so forth. Now, since the beginning, we've been very excited about the idea of bringing those capabilities to help developers create intelligent pipelines. The way that we see it, that starts with giving pipelines visibility into test results. But we go beyond that. We want to help the pipelines themselves understand risks associated with changes. Again, things like visual changes, performance changes, and so forth. And we think that providing that context will allow developers to create very sophisticated workflows to automate a lot of the manual intervention that's required today to get code from development into production. And so that started for us with building an action that will trigger Mabel tests. And so it's a very simple action. It accepts as inputs information about your application, environments, deployments, and also allows you to override the configuration of your test plans if needed. And then it returns the results of your tests. How that works, you may have a workflow that has a deployment step, then you'll have a step to run Mabel tests. That step notifies the Mabel Deployments API, which will in turn trigger your tests to run in Mabel. Now, as those tests are running, the Mabel action queries the test results API, pulls the test results API, and brings those results back into your workflow. Now, I'll show you a very simple example of how that plays out. Here, we're making a change to a simple HTML file in our repository. As one does, I'll commit that change straight to master, and this will trigger our run Mabel tests action. Now I can watch as that action kicks off. Right now it's notifying the Mabel Deployments API that a deployment's available. Now the test is running, and we're looking in Mabel as those tests are running live. Now here you can see Mabel collecting all that rich data. We have screenshots. You'll see in a moment that we're collecting snapshots of the DOM at every step of the test. We're also collecting page load information at every step of every test. Now our tests are complete, and they've all passed. Now the important thing here is that this context is available to the pipeline. So as a developer, I can trigger additional automation off those test results, like that simple deployment that I just made, the test pass, I probably just promote that to production right away. Today, we're excited that we've extended our action support to the Mabel CLI. So what that means is from actions, you can call all of the features that are available from the Mabel CLI. For example, we have a customer that will use that to, after the test run, to take those screenshots that Mabel captured and then use the AWS CLI to store them on S3 for archival and compliance purposes. Okay? But I know that many of your workflows are much more sophisticated than that, right? And what you really want is to understand, as I mentioned, the risk associated with your code deployments. Now, Mabel assesses that risk today, and we provide insights, but those insights have historically always been to developers, right? And we'll provide Slack notifications today, or we'll send you an email. Today, for the first time, we've made pipelines aware of those insights. And so as of today, the Mabel GitHub app can generate events in your repository when Mabel discovers risks or issues within your application. And the power of actions is then you can use those events in your workflows to trigger or control additional actions. Right? So for example, you may, great, all of my tests passed, but I may also want to confirm that Mabel didn't discover any regressions from a performance perspective, right? Or new JavaScript errors that show up in the console, or what have you. So that's available today, and I think these are three really good examples of the power of bringing together testing information about the risk associated with deployments, and making that all available in this flexible platform in Actions. Now, if you'd like to see it working live, you could stop by and see us at the Partner Innovation Connect event this afternoon from 12 to 2. And thank you very much. We'll welcome Erica back to the stage.
Thanks, Dan. And thanks to all of our presenters today. It's so cool to see the way that different members of the community are coming together to work on addressing challenges such as software security via token scanning, security research, container scanning, and more. I also love seeing how the combination of products and projects from across the ecosystem can automate manual work for developers via solutions for cross-browser testing, code to cloud, notifications, and more. In a world with over 100 million developers on GitHub by 2025, the creativity of our development team can never match that the creativity of the world's developers. It's only through collaboration that we can jointly deliver everything needed to support all of the different ways that people want to build software together. We look forward to continuing on our mission to be the home for all developers and to work with the software development community to provide the canvas on which the world's developers can do their best work. Now, before I wrap up, just a few quick notes. First, stop by the Partner Innovation area, as Dan mentioned. From 12 to 2, we have a variety of partners who will be showing their actions, and they can also answer your questions about what it was like to build actions and give you some pro tips. And also, stop by the Ask GitHub booth, where we're staffed with support folks, engineers, and others from across GitHub to answer all your questions, and also, of course, to collect your feedback and hear what you'd like to see next from GitHub. With that, thanks everyone for being here, and have a fantastic day at GitHub Universe.